Hi everyone, so this is the second part of chapter 1.5 algebraic division of the year 2 pure book, and what we did in part 1 was we looked at what an algebraic improper fraction is, and we looked at converting them into mixed numbers. Now what we will do in this video is we will look at actually taking an algebraic improper fraction and splitting it into its constituent partial fractions, and the process that we learnt last lesson will be used to do that, because we must turn it into a mixed number first. So we just have one example in this part of the book, which is example 14. And example 14 says, given that 3x squared take away 3x minus 2 all over x minus 1 times x minus 2 is identical to a plus b over x minus 1 plus c over x minus 2. We need to find the constants a, b and c. So what I would first be thinking if this was an unseen question is I'd be thinking, okay, so I'm converting an algebraic fraction into partial fractions. I can see that quite clearly. But I'm also thinking, well, actually, the denominator would have degree 2 if I expanded the brackets. In fact, we need to expand the brackets, so we might as well do that now. If I expand the brackets in the denominator, I get x squared take away 3x plus 2. So I'm dealing with an improper fraction because the degree of the numerator is 2 and the degree of the denominator is 2. So before I start to do any partial fractions methods that I know, I'm going to need to convert this into an improper fraction, into a mixed number. So I'm going to use algebraic long division to do that because of the format that my question was given to me in. It's given to me as a constant, or a function. This isn't a function, this is a constant plus a remainder divided by the divisor. So I'm first going to complete this division. So I need to do 3x squared take away 3x minus 2 all divided by x squared take away 3x plus 2. So I'll do 3x squared divided by x squared, which is 3, and then I will multiply the whole of the divisor by 3, so that's 3x squared take away 9x plus 6, and I'll subtract to get negative 3x take away negative 9x, which is 6x, and the negative 2 subtract 6, which is negative 8. So I can now write my my initial improper fraction as 3x squared take away 3x minus 2 all over x minus 1, x minus 2, and that is exactly the same as 3 plus 6x minus 8 all over the divisor x minus 1, x minus 2. So this would have been the stage that we went up to in the last lesson, was changing an improper fraction into a mixed number. Now what we're going to do is we're going to use our partial fractions methods to separate this remainder into its two partial fractions. So I'm just going to consider the fraction 6x minus 8 all over x minus 1, x minus 2, and I'm going to make that equal to b over x minus 1 plus c over x minus 2, and this is going to be equal to, if I write this as over one common denominator, and I can then write the identity, or I can equate the numerators, that 6x minus 8, so the numerator here is identical to the numerator here. And then here you can either use equating coefficients, or you can use substitution, but I will use substitution just because it is a bit faster. So I'm going to substitute first x equals 2, and that gives me, well, 6 times 2 is 12, take away 8 is 4. This term will disappear because x minus 2 will be 0, and then 2 take away 1 is 2, so 4 equals C. And then I will substitute in x equals 1, and I'll get 6 take away 8, which is negative 2, and then 1 take away 2 is negative 1, so I'll get negative b, so that tells me that b equals 2. And I can now go all the way back to the beginning, because I know these constants a and b, which allow me to write this remainder here that I got from my algebraic division as partial fractions. So I can go all the way from this stage, and I'm going to write my initial improper fraction, 3x squared take away 3x minus 2, all over x minus 1x minus 2 is exactly the same as 3 plus 2 over x minus 1 plus 4 over x minus 2, and then I can state the constants as well. So a was 3, b was 2, and c was 4. So that's my final answer. So we've now done the full method of firstly converting an improper algebraic fraction into a mixed number, and then converting the remainder of that mixed number, which was this, into its partial fractions. So yeah, so that's example 14, and you will now be able to complete the rest of this chapter's questions.